For part 4, I need to explain a bit. So let's just follow me very, very closely. So if the null hypothesis in 2 is rejected, at 5%, what can we reject the null hypothesis at 1% level significance? Okay, explain why. So let me explain to you. 5%, if it's rejected. So I'm going to look at this. Let's just draw what does rejected mean. So this part here, we have got 2.5% and 2.5%. Okay, so when you're rejected, if you're rejected at 5%, it's like that. So the question now is, if you change this test, this is an alpha percentage. It's 5%. This is alpha percentage when it's 1%. Means this curve here would cut this side here. This area here would be smaller, so this is half a percentage, or rather 0.5%. This part is 0.5%. Okay. Now, if you reject H naught, one thing for sure, reject H naught. One thing for sure is your Z stat will be where? If you already reject H naught, your Z stat is actually either lesser than this boundary here, which we just now found, which is negative 1.95, and this is 1.95, right? So it's negative 1.95 or Z stat is more than 1.95, right? So let me explain to you. Z stat can be anywhere here. So it could be anywhere here lah. So here, it could be here, it could be here. As long as, because you reject H naught, means Z stat could be here. It could be very, very at the end there or here, near to 1.95. It could be here, anywhere lah, anywhere here, right? So the question now is, when you change the test statistics to a 1% level of significance, right? Would you also reject H now? Okay, so let's say if it's here, can you conclusively say that it will be within the 0.95% here? Okay, just so you know, when you do your inverse norm, right? Your inverse norm, right, 0.5%. Inverse norm 0.5% is 0.01 divided by 2 on the left tail. Is actually a very, very is actually minus 2.7, 2.5. So let's say this is minus 2.58. Right? Obviously, it's not conclusive, right? Okay, it's not conclusive, right? So obviously this is not conclusive. You cannot conclude that it will definitely reject H naught when it's at 1%. So how do you write? Since we reject H naught at 5%, this has a hold true, right? To reject H naught at 1%. Okay, we need Z stat to be less than minus 2.58, or Z stat more than 0.8, definitively. Thus, the test is inconclusive at 1%. Okay. You cannot tell whether Z stat is, because for all you know, Z stat can be 1.96, and 1.96 at 1% level test will not reject, so it's about here. Okay. So that's how you write if you want to use a Z stat way. The answer key they actually write in the p-value way. You can also write the p-value way. the p-value way is easier actually to write. So I will just write down method 1 using critical values method, classical. Okay. Okay, I'll just pause here. Any question, can you please unmute yourself and ask? You're not sure, just so for p-value method, it's actually much simpler to write. So method 2, p-value method. So what you write is test, right? Because you test h naught mu naught h1 mu not equals to mu naught. So you reject h now at 5%, right? This will mean that p-value is less than 5%. Okay, so p-value, it doesn't imply, this doesn't imply p-value is less than 1%. Hence, test is inconclusive at 1% significance level. Okay, so the p-value method is actually much easier to write. Yeah. So I will suggest. Anyway, we will upload this hub to the portal. Any question, just let us know. Okay. Okay.